Dear students, thank you very much for coming again to this third part of the ECORETINA lecture. Now I'm going to present a case study, and the objective of the case study is like an example which is a comparison between ECORETINA and a neural network using a specific database that uses 50 explanatory variables, and it is related to the diamond price. We are going to use a training dataset with 115,000 observations and a test dataset with 38,000 observations. The methodology that we are going to use is we are going to vary the number of explanatory variables and also the training set size to be able to analyze what are the differences in behavior between ECORETINA and a standard architecture neural network. The metrics that we are going to use are the mean absolute prediction error and the CO2 emissions due to the training. In this transparency, we see that we have the MAPA and the mean absolute prediction error that we are going to use it to compare the performance of ECORETINA with respect to a neural network. You see that we have three panels there. We are only going to look at the left-hand side because the panel on the middle and the right are similar in the sense that they only have less observations. So we are going to look always at the left-hand side panel, and in that panel, lower is better. You see that neural networks have a lower mean absolute prediction error, and that means that they are more precise. They are actually slightly more precise for the number of variables that we are using in this comparison. In terms of CO2 emissions, that is quite different because in this case, if you look again to the left-hand side, you will see that there are a lot of difference between ECORETINA and neural networks. The lower is the better, so ECORETINA is much better in terms of CO2 emissions. The training duration here is another variable that we look at, and you see that the training duration of ECORETINA, if you look at the left-hand side panel, you see that it is much smaller than the duration that it takes to train a neural network. Also, if you look at the mean square error, you see that the differences are not that big, but still neural networks does a little better than ECORETINA on the left-hand side. Something that we cannot compare between ECORETINA and neural networks are the prediction intervals. The prediction intervals are only given by ECORETINA and not by neural networks. So that is a net improvement here. And you look at the differences between the point prediction, which is the black line, and the red lines, which are the upper bound and lower bound for the prediction. You see that it is very informative to know whether the point prediction is between or is close or is different from the upper and lower bounds. This is something specific to retina. And you see also a different thing here, which is the example output, and this is again related to the diamond data set, and the idea is that we have regression results that are linear regression results, and they have, you see, a high R square, and it is estimated by ordinary least squares. You have F statistics, you have all kinds of diagnostics that are typical, the degrees of freedom of the residuals, degrees of freedom of the model, and you also have the, in the column here, constant, and below you find the names of all the transformed variables that are going to be useful for out of sample forecasting. So that is a carat weight times depth percent to the -1. So that is carat weight divided by depth percent, and that is one of the most important explanatory variables in terms of out-of-sample prediction capability of the model. The model is specific, the model is completely transparent. It gives you exactly what are the weights of each of the transformations, and it gives you p-values also, and so it is not a black box, it is very transparent, and it is useful for out-of-sample forecasting. You also have other diagnostics here, which may or may not be useful depending on the what you want to do with the model. But with this model, you can interpret it, you can change it, you can modify, you can reproduce it, so you can do whatever you would like to do, similar to any OLS type of model. The conclusions are somewhat interesting here. They tell you that MAPE of neural networks is somewhat smaller, but emissions are substantially smaller for retina. ECORETINA outperforms neural networks in accuracy for a moderate number of inputs, and the speed of carbon footprint is and transparency convert ECORETINA in a green AI algorithm. MAPEs are similar, and in practice the conclusions are also very similar. ECORETINA is a modular, transparent, and amenable to interpretation algorithm. The conclusions, second part of the conclusion is that ECORETINA gives you explicit forecasting model based on the transformed inputs. It gives you coefficients, T statistics, F statistics, coefficient of determination, and several diagnostics. So it is useful for knowing what is inside the algorithm and what is inside the answer that it gives you. ECORETINA and neural networks are substitutes and complements, and of course we need more experiments across data types and sizes, and that is what we are doing precisely now. Why now? Because there is a need of green AI algorithms which can be run in powerful PCs and used also for cloud computing and treat massive data. The applications are varied. across different disciplines, applied work, teaching, medicine, economics, and it is a fast and interpretable algorithm. It is open in the sense that you can see the code and change it if you want to, and it is available in GitHub. You see there the HTTPS direction that you want to look at, and you may want to go inside and download the program and run it in your computer. Okay, so this is still in the testing phase, but we are going to have it second version pretty soon. Okay, thank you very much for attending these lectures, and I hope that they are suggestive and interesting for you. Thanks.